Hey crew, these are your topic 3-4 review notes. We've been learning new material, but we also need to be reviewing old material because this is really important for just for tools we need for calculus. So in these topic 3-4 notes, which are going to help you finish this week's review quiz and then start next week's review quiz, we're going to talk about solving inequalities. So the first thing we have is solving linear inequalities. So if, for example, I gave you 3 minus 2x is greater than or equal to 5. If I wanted to solve for that, I'm going to solve just like I solve an equation. So for here, I would subtract 3 and I would get negative 2x is greater than or equal to 2, and then my next step would be to divide both sides by negative 2. And the one thing we need to remember here, right, we would get x, is that when we multiply or divide by a negative, we have to change the direction of our inequality signs. So instead of greater than, this becomes less than or equal to 1. So I think you'll remember doing that. Now let's talk about solving polynomial inequalities. So here's an example we're going to use here. Move this over a little bit. So let's say that I have, for example, 2x squared plus 5x minus 12 is greater than 0. The first thing we're going to do is we're going to factor this polynomial. So we would get 2x minus 3 times x plus 4. And then from that, we're going to build a table. So this is going to be my top row, and then I'm going to make a column before, between, and after my factors. So I'm going to pull down, I want the product of these two factors to be greater than 0, and then my first column is going to be for x. So I'm going to come in here and I'm going to first find what would make my factors each equal to 0. So I'm going to find my zeros. So I'm going to find what would make 2x minus 3 equal to 0, which would be when x is 3 halves. And I'm going to find when x plus 4 would equal to 0, which is when x is negative 4. And now I'm going to treat this first line like a number line that I have turned from being horizontal to vertical. And I'm going to put my zeros smallest on top, so this is at negative 4, and then my other 0 is at 3 halves, which would be bigger, so I'm going to put here. And then in between those, I'm going to consider any x's that could fall below or above. So I'm going to come in here and so we'll take this lovely little orange. And I'm going to consider now x's that are less than negative 4, x's that are between negative 4 and 3 halves, and x's that are greater than 3 halves. And I'm going to just test a number that falls into that category. So I think for my test values, let's do this. So a number less than negative 4 might be negative 5. A number between negative 4 and 3 halves might be 0. And then a number bigger than 3 halves might be 2. And I'm going to take those numbers and plug them into each factor to determine whether it gives me a positive or a negative. So if I plug negative 5 into 2x minus 3, I get negative 10 minus 3, which is negative. If I plug negative 5 into x plus 4, I get negative 5 plus 4, which is negative. So these zeros make the columns of our table. Okay. Now, if I multiply a negative by a negative, I get a positive. And I want a positive. That's good. All right, so if I come in here, let's use our highlighter here. So I want positive, that's good. So I'm going to use x's that are less than -4 as a solution. Okay, now let's go back and let's plug in 0. So this time if I plug in 0, right, 2 times 0 minus 3 is -3, so that's negative, and then 0 plus 4 is positive, and a negative times a positive is negative. I don't want any negative numbers, so I'm not going to include my interval of x's in my solution there. Now I'm going to plug in 2, and 2 times 2 is 4 minus 3 is positive, and then 2 plus 4 is 6, which is positive, and a positive times positive is positive, right? I'm looking for greater than 0. Positive is greater than 0, so x is greater than 3/2 are going to be in my solution. So my final solution then is going to be that as long as x is less than -4 or x is greater than 3/2, then my original equation will be true, and that's my solution. Okay, so that's solving polynomials equal to polynomial inequalities, which is summarized in our steps here. Let's look at solving absolute value inequalities. So for here, I'm going to take as an example the absolute value of 3x minus 5 is greater than 7. If I have an absolute value greater than, then my distance from 0, that's definition of absolute value, has to be beyond 7, which means that 3x minus 5 must be bigger than 7. But because the absolute value changes a negative to a positive, then if a negative number is more than 7 away from the origin, it's actually left of -7 or less than -7. So my other possibility would be that 3x minus 5 is less than a -7. I solve those and I get 3x is greater than 12, or x is greater than 4. And from the other one, I get 3x is less than -2, x is less than -2. So my solution would be that x can be less than -2 or x can be greater than 4. Okay, now let's look at an example where the absolute value can be less than 4. So if the absolute value can be less than 4, right, then whatever's inside your absolute value must be closer to the origin than whatever k is, closer to 0, so it must be in between the positive or a negative. So here's my example there. If I take absolute value of 4 minus x is less than or equal to 7, right, then the distance from 0 has to be less than 7, which means that 4 minus x must be less than or equal to 7, right? But my other possibility is that 4 minus x is actually greater than or equal to -7. To solve this inequality, we're going to subtract 4 from all three sides, so we get -11 less than or equal to -x less than or equal to 7. Then we're going to divide by a negative, which makes this positive. Dividing by a negative, I have to switch the direction of my signs, so my less than's becomes greater than, and 7 divided by negative is -7. These kind of inequalities we always write as smaller, less than, and then bigger. So I'm going to switch this around and rewrite it as -7 less than or equal to x less than or equal to 11. Let's look at 2 more examples here, and these actually can be very easy if you think about them. So let's take the example where the absolute value of 2 plus 3x is greater than -12. Right, because absolute value, this was 2 plus 3. This was absolute value of 2 plus 3x. Because the absolute value changes every negative to a positive, it will never be negative. The smallest it could be is 0, which means that the result of taking an absolute value will always be greater, right? Always greater than any negative number, which means that x can be anything, all real numbers, right? That statement is always true. If in contrast I were to take something like the absolute value of 1 minus 9x, absolute values, is less than negative 6, right? I'm asking an absolute value to be less than a negative, and because the smallest that absolute value can be is 0, and 0 is not less than a negative, neither would any positive number be less than a negative. This would be no solution. I think I'm going to stop here, and I'll do another little video for you next week on redefining absolute value functions as piecewise functions.